Good afternoon. I'm meteorologist Will Harkins, and I will be briefing you on Wilmington, Ohio for September 27th, 2012. As we take a look at the 500 millibar hemispheric chart for 0Z of the morning of the 27th, you can see we have roughly a wave number of 5 as indicated by the troughing pattern. You notice across the United States we're predominantly sitting in the middle of a long wave ridge with a long wave trough sitting on the eastern seaboard. As we move ahead to 12Z, you can see there's a slower progression of the long wave pattern with a short wave indicated just north of Minnesota and Manitoba. For those of you who are unfamiliar with universal time, 0Z or 24Z is the universal timestamp. For Central Standard Time, you subtract 6 hours from this 24-hour clock, which would give you a time of around 18 military time or 6 p.m. For Central Daylight Time, you would subtract 5 hours, which would give you a local time of around 7 p.m. For 12Z, it is exactly 12 hours later, so it would be 7 a.m. or 6 a.m. for Central Standard Time. As we move ahead to the 250 millibar chart, you can see that there are two wind maximum located in northern New York and northern Maine. For those who are unfamiliar with four-quadrant jet theory, it states that if you have a jet maximum, as indicated on this chart by the darker blue center, on the western side of this jet maximum, you have a left entrance and right entrance. And on the right side of the chart, or eastern side, you have a left exit and a right exit region. The right entrance is considered a divergent region, and the left exit is also considered divergent, with your left entrances and right exit regions being convergent. What does convergence and divergence mean? Well, on a synoptic scale in the upper atmosphere, if you have divergence, as indicated by the arrows pointing away from each other, you have a void of air, which is replaced by air from the vertical column beneath it. So you get a rising motion. This rising motion generates lower pressures and convergence at the surface, as indicated by the large red L. For convergence aloft, you have winds coming together in the upper atmosphere. These winds have to go somewhere, so they go downward, and this gives a general sinking motion in the vertical column and generates high pressure and divergence at the surface. As we skip ahead to the 12Z chart, the wind maximum that were located in the northeastern United States have moved off to the northeast and are in southern Newfoundland. Looking now at the 500 millibar 0Z analysis, we see a shortwave trough stretching across our area at 0Z last night, with two ridges located in Saskatchewan and Manitoba. As we move ahead to the vorticity chart, we can see we have a vorticity maximum located in southern Ontario, and a large area of vorticity stretching from this vorticity maximum back westward into Colorado. What is vorticity? For positive values of vorticity, as indicated by the green circle, you have a cyclonic turning, or what would translate to lower pressure. With negative vorticity values, you have anticyclonic turning, or higher pressures. This is a good indicator of where we can find the center of our systems at the 500 millibar level. As we look now at the 500 millibar 12Z analysis, we can see a long wave trough stretching from northern Ontario all the way down into Colorado. This will be advecting into our region later this week. Additionally, we have a short wave, which is not indicated here, but a short wave indicated via cyclonic turning of the winds, as you can see from our station ID in southern Ohio. And then again, you have a northerly component of wind back into Illinois. This is giving a cyclonic turning of the winds, which means we have a short wave stretching across Indiana. As we look now at the 500 millibar vorticity for 12Z, you can see where that short wave is located in Indiana, with the vorticity maximum centered around Indiana and stretching all across Illinois, Indiana, and into Ohio just over our station. As we take a look now at our 700 millibar at 0Z last night, we can see a large area of moisture across the central United States associated with that shortwave. Looking ahead to 12Z this morning, we have a large stretch of dry air that has been advected into the system across Illinois, stretching from the Gulf Coast up through Illinois, and back west of this drier air we have a large pocket of moist air. Over our station, Wilmington, Ohio, we again see a pocket of moist air associated with rain and thunderstorms in our area at this time. Looking at the 850 millibar chart for 0Z, we see there's not a whole lot of warm or cold air advection across the continental United States. There are a couple of weak pockets of warm air advection across Kentucky up into these southern Ohio River valleys. However, this is very weak warm air advection. You can also there's also indications of cold air advection in northern Illinois. However, most of our warm and cold air advection is occurring in Canada, and even these are still quite weak. As we move ahead to 12Z this morning, we can see a westward progression of all advection areas. The weak advection that was in the central United States is still very weak, but is now is still visible just east of the state of Ohio, with some warm cold air advection still present across Illinois. As we take a look now at our 0Z surface chart, we can see a very long stationary front stretching from Newfoundland down into the central United States all the way back almost to the western coast of the United States. As we look ahead at 12Z, we see a center of low pressure developing in central Indiana as a result of the short wave I talked about earlier. As we move this forward to 15Z, we see that low pressure center is now moving off towards the east into Ohio, with a stationary front still indicated stretching from the low pressure center back down into central Oklahoma. However, at 18Z, the stationary front is now analyzed as a cold front. The low pressure center is now moved off into eastern Ohio. Taking a look now at a high density surface observations, we can see we have a general eastern component of wind north of the front with a westward component of wind south of the front. Our station ID is centered around southwestern Ohio and is indicated by the ILN. Winds are clearly out of the west at 15 knots, indicating that the front has yet to pass. Taking a look now at radar observations, we can see that there are widely scattered showers and thunderstorms off to our east. These were, however, in our area this morning. As we now take a look at the satellite imagery, we see we are getting some clearing in the clouds, mostly due to that dry air that was being pulled into the system as indicated on the 700 millibar charts. We have a large cloud field and vortex in eastern Ohio indicated as a result of the low pressure wave that we see moving off to the east. Off to the west in Missouri and Arkansas, we see another large cloud field. This is associated with that large band of moisture, also indicated on the 700 millibar 12Z chart. As we take a look now at the SKU-T for 0Z, we see that there's general veering of the wind profile, which is an indication of warm air advection, although this is very weak warm air advection. It is a relatively moist profile with dry air indicated just above the 700 millibar level, extending up into about 550 millibars. Looking at the SKU-T for 12Z, we see an even more moist SKU-T with moisture stretching from the surface all the way up into the upper parts of our troposphere. The reason for this moist sounding is because this morning at the launch of the weather balloon we did have rain. Taking a look now at the meteogram, we can see that as of 17Z last night we had pressures around 1018 millibars, as indicated on the bottom section left side. We see a general rising of the pressure as we progress all the way through 17Z. Just above this, you can see an indication of where the cloud deck is. For the most part, the clouds have been low clouds around 5,000 feet, and sometimes getting down as low as below 1,000 feet. Winds have been progressively out of the south, as indicated by the wind barbs just above this. Our temperature profile has been actually quite cool. We saw yesterday we had our spike in temperatures around 19Z, and it progressively got colder as the night went on. However, for today, due to the cloud cover and precipitation, we've been holding steady at around 63 degrees Fahrenheit. Looking now at the forecast vorticity for 0Z tonight, we can see the stretching of vorticity all across the central United States from eastern Ohio all the way back through into Colorado, which gives us a good indication of where we can find our front. As we take a look now at our forecast map, you can see I have a low pressure center analyzed in northeastern Ohio, with stationary front extending westward south of our station back off to the far west. I believe that the front will have passed by 0Z tonight, and we will have winds out of the east at 10 knots. Temperatures will be around 67 degrees Fahrenheit and a chance of rain. Again, these are widely scattered showers and thunderstorms. Taking a look now at our 24-hour vorticity map, we see that the vorticity that was stretching across the central United States has weakened some, as the low pressure center is being picked up by this long wave off to the north of the Great Lakes in eastern Ontario. As we look now at the forecasted, we can see that our stationary front has drifted a little bit further south. This is more than likely a cold front at this point. Temperatures will drop off to around 57 degrees, with the atmosphere drying out down to around a dew point of 48 degrees. Winds will still be out of the east at about 5 knots. We can expect broken skies with mid-level cloud deck. This has been an introduction to weather briefings and what operational meteorologists do on a daily basis. Again, if you have any questions regarding this video, please feel free to leave a comment, and I'll be sure to get to them in my next video. Thank you for listening.